Today, I'd like to talk to you about inequalities. And when we're dealing with inequalities, we want to use our symbols. So what symbols do you think of when you think of an inequality? Greater than? Well, when we have something like x is greater than 2, and before when we graphed it, we would put an open circle at 2 and go to the right. But now that we're going to use interval notation, we're no longer going to use open or closed circles. We will use parentheses. So rather than have this open circle at 2, we are going to just put a parenthesis opening to the right, because greater than are to the right of those numbers. We also have a less than symbol. So if I change this to x is less than 2, when we're going to graph it, we're still going to be at 2, but the numbers to the left of 2 are less than. So we'll have a parenthesis opening to the left. And so I do want to point this out, that to the left are negative numbers. So we call this end negative infinity. So in interval notation, we would say it goes from negative infinity, comma, to 2, parenthesis, because there is no equal sign. Up here, we would have gone to the positive numbers, positive infinity. So we began at 2, and we went to positive infinity. 2 had a parenthesis, infinity always gets a parenthesis. We could have greater than or equal to, or less than or equal to. If I am going to do greater than or equal to, x is greater than or equal to 2, then I'm going to use my brace. So I'm still at 2, but I'm to the right of 2 and equal. So I put a brace on it. So there's a brace on 2. The numbers to the right head towards positive infinity. So from 2 in a brace to positive infinity in parentheses, because infinity always gets parentheses. So then if I did the less than or equal to 2, again I'm at 2. Less than is to the left, but I'm equal, so I use my brace, not a parenthesis. To the left of 2 are negative numbers, so it's negative infinity. This time I begin left to right, from negative infinity to 2, closed in a brace. When we're using these inequalities and solving inequality expressions for them, there are basically 3 rules to follow. I like to think of it as one rule, but I'll go through the 3 to get to the 1. When we add or subtract any number, there is no effect on the symbol. So let's pick 2 numbers. 2 compared to 5. 2 is less than 5. If I add 3 to both sides, 5 compared to 8, still less than. How about if I subtract 3? Two minus 3 is negative 1. 5 minus 3 is 2. Negative 1 is still less than 2. So it does not matter if I add or subtract, I still have the same symbol. Let's try multiplying and see what we get. Multiply by a positive. Multiply by 3. Multiply by 3. 6 compared to 15. 6 is still less than. Did not change it. How about if I divide? Let's divide by 3. 2/3 compared to 5/3? 2/3 is still less than, so it does not change it. Well, let's try multiplying or dividing by a negative. Divide by -2, divide by -2. -1 compared to -2.5. -1 is to the right of -2.5, so now my symbol switches. So to me, there's only this one rule. Multiplying or dividing by a negative switches the symbol. That's when the bells and whistles should go off. You should hear the train whistles. Whoop, whoop. Gotta flip it. Every time I multiply or divide by a negative, gotta flip it. Let's practice some. $11y minus 9 is greater than 13. We're going to add 9 to both sides. $11y is greater than 22. Divide by 11. Y is greater than 2. And we're going to do everything in interval notation. So here's 2. Everything greater, I'm not equal, so I use a parenthesis, and I'm going to the right of 2. So my parenthesis opens to the right. So to say what the answer is, it starts at 2 in parenthesis, and it heads towards the positives. Positive infinity in parentheses. So this would be considered your work algebraically. This would be your graphical solution. This would be your symbolic solution in interval notation. Let's try another one. 7x plus 9 is greater than or equal to 10x minus 12. Let's subtract 10x. Negative 3x plus 9 greater than or equal to negative 12. Subtract 9. Negative 3x greater than or equal to negative 21. Divide by a negative. Woo, woo, negative. I have to switch my symbol. X is less than or equal to 7. So I'm here at 7. Less than is to the left. Since I'm equal, I'm going to have a brace opening to the left. To the left of 7 are where all the negative numbers occur. So I begin with my negative infinity. Infinity always goes in parentheses. And I end with 7 in a brace. Algebraic work, graphical representation, symbolic representation in interval notation. Now let's try this one. Negative 12 is less than 3x minus 3, which is less than 15. This time I have 2 inequality symbols. Whenever I have 2 inequality symbols, I have to take what's in the middle and pair it to the front, and what's in the middle and pair it to the back. So that means negative 12 is less than 3x minus 3, and 3x minus 3 is less than 15. Now solve each. Add 3. Negative 9 is less than 3x. Divide by 3. Negative 3 is less than x. So if negative 3 is less than x, x would be greater than negative 3. Now let's solve our second. Add 3. 3x less than 18. Divide by 3. x less than 6. So I have a negative 3 and I have a 6. I am greater than negative 3, so I'm to the right of negative 3, so I put a parenthesis. I am less than 6, so less is to the left, and I put a parenthesis. So it looks like I'm beginning at negative 3 and ending at 6 and closed in parentheses. All the numbers between negative 3 and 6 should work. And if you're ever wondering, you can go back and check your answer. I'm going to use this one because this is where we switch the sign. Let's pick a number less than 7. Say 0. So if I take my original equation and I substitute 0 in, I would have 9 is greater than or equal to negative 12. Is that true? Yes, it is. So I know that this solution is correct. Okay. Let's try number 5 because of that fraction. 0 is less than 7x minus 5 over 3, and 7x minus 5 over 3 is less than 4. Multiply both sides by 3. 0 times 3 is 0, is less than 7x minus 5. Add 5. 5 is less than 7x. Divide by 7. 5/7 is less than x. So x is greater than 5/7. And I want to change this one to an equal bar so I can show you when you don't have the same sign. So let's do the same thing to the other one. Multiply both sides by 3. 7x minus 5 less than or equal to 12. Add 5. 7x less than or equal to 17. Divide by 7. X less than or equal to 17/7. So on my number line, I have 5/7 and then I have 17/7. I'm to the right of 5/7 and I'm to the left and equal of 17/7. So I need the brace. So I begin at 5/7 and head towards 17/7 with a brace. All right. Now let me show you how to do it graphically. Again, we're going to make this one f of x, this one g of x. So y1, y2. So we would have y1 equals 2x plus 6, y2 equals 10. So 2x plus 6 crosses at 0, 6, slope 2, up 2 over 1, up 2 over 1, up 2 over 1, down 2, left 1, down 2, left 1. Just so I get a nice line, I'm doing a whole bunch of points. There is 2x plus 6 equals y. Now let's do y equals 10. Y equals 10. Right here is where the two meet. I am looking for where they're equal, so I need that point. But I'm also looking for greater than 10. Well, here's 10. Where does the pink line go greater than 10? Above 10, right here. But I'm solving for the x values. So I take this point down to the x-axis and I get x is 2. I am equal at 2. And are they the points to the right of 2 or to the left of 2 that give me this highlighted part? To the right of 2. So I am also greater. Now let's convert that to interval notation. I start at 2 with an equal sign, and I head towards positive infinity with a parenthesis. And if we look at the table feature, take a minute for my calculator to get in here. Y1 was 2x plus 6. Y2 was 10. And I want to go to the table. I'm looking for where both y values are 10, and that happens at 2. I'm looking for where they are greater than that 10. Here's where the y values go greater than 10. What x's show those greater than 10? Down the table. So that would be heading more positive, going greater than 2. I'm going to take a picture of this so I can paste it in here and highlight it for you. That's not what I wanted. Here's our table feature. I'm going to make it a little bigger. Right here is where I was exactly 10. I'm looking for bigger than 10. That happens there. That is these x values. So I'm going 2 and larger. 2 and larger. So again, I'm equal at 2 with the brace. Larger is towards positive infinity with a parenthesis. Let's try another one. Press your y equals. I believe this one says there are variables on both sides. We're going to put them on one side of the equation. So let's first do that. I am moving all of this. So right now, it's added. I'm going to subtract the works. No algebra. Subtract the parenthesis worth 1/2 x plus 1. And then I would have 0 left on this side. Remember, fractions have to go in parentheses. So here I'll have a double parenthesis. Now let's pull up that calculator. Y1. Parenthesis 3 divide 4 parenthesis x minus double parenthesis 1 divide 2 parenthesis x plus 1 close parenthesis, and then y2 is 0. Hit enter. Now I don't know where we were last, so I'm just going to do zoom 6 so we go to our negative 10 to 10, negative 10 to 10 window. There, and here comes our 0. All right, I'm going to take a picture of it so that I can highlight. Nope, not what I wanted. Let me try it again. There we go. That's the one I wanted. So, let's look what we're looking for. Less than 0. Well, this is my 0. Y equals 0. Where does the graph go lower than that? Right here. And it looks like I should have done that intersection. So let's pull up the calculator And let's calculate the intersection. Yep, first curve. Yep, second curve. I'm going to guess there. It's at 4, 0. That's actually probably what I want the picture of. I'll get it yet, guys. All right, let's ditch this stuff. So again, here was my 0. Where does it go below? Right here. I'm not equal, so I'm not going to be equal at this 4. But where does the graph go below? To the left of 4. To the left of 4 is towards negative infinity. So I start at negative infinity, and I close at 4. Let's apply to life. Milk in its expiration date will not freeze when it's stored at a minimum of -1 degree Celsius and a maximum of 5 degrees Celsius. Write the inequality that shows these temperatures in Fahrenheit. And they gave you the conversion. So the conversion is going to go between -1 and 5. So we have two problems. -1 less than or equal to 5/9 f minus 32. And 5/9 times f minus 32 is less than or equal to 5. Multiply both sides by 9/5. -9/5, which is -1 and 4/5, -1.8. Less than or equal to f minus 32. Add 32. 30.2 degrees less than or equal to Fahrenheit. So Fahrenheit is greater than or equal to 30.2 degrees. Let's do the same on this side. F minus 32 is less than or equal to 9. Add 32. F is less than or equal to 41. So my Fahrenheit temperature starts at 30.2 and to the right and equal, so brace, ends at 41 and to the left. So 30.2 to 41 degrees Fahrenheit with braces. You should now be able to start your assignment.